Bismillahirrahmanirrahim. Assalamu alaikum dear viewers. I am Dr. Noshin Afshan and you are watching Dr. Noshin Afshan YouTube. उम्मीद करती हूँ कि आप हमेशा की तरह बहुत खुश होंगे और इस वीडियो को देखने के लिए आपकी बेहद मशकूर हूँ और मज़ीद वीडियोस देखने के लिए मेरे इस चैनल को सब्सक्राइब करें और बेल आइकन को भी प्रेस कर दें। सो नाउ लेट्स बिगिन। हमारा आज का टॉपिक है डायाजीन्स, जिसमें हम देखेंगे डायाजीन्स का इंट्रोडक्शन, इसकी टाइप्स अलॉन्ग विद देयर स्ट्रक्चर फार्मूलाज and their general properties and the synthesis of one example of the diazenes, that is pyridazine. So we will study the synthesis of pyridazine along with its mechanism also. So now what are the diazenes? Actually it consists of two words, that is di and azenes. Di means two and aza indicates the nitrogen. So it indicates such compounds which contain two nitrogen atoms. So let's see what are the arrangements of the two nitrogen atoms. So in the ring systems or in aromatic compounds, if the two nitrogen atoms are placed at ortho position or 1,2 position, then such compounds are called as pyridazine. And if the one nitrogen is placed at the meta position with respect to the other nitrogen, like this one, and this meta position is also called as 1,3 position. So if two nitrogens are placed at meta position or at 1,3 position, then these are called as pyrimidine. And if these two nitrogens are at 1,4 position, then the compound would be called as pyrazine. So in this way, all these are aromatic in nature and same like benzene, but the only difference is that the two nitrogens in these diazenes substitute the two carbon atoms in the benzene ring. So these such type of aromatic compounds consisting of two nitrogens at either 1,2 or 1,3 or 1,4 position are called as diazenes. The examples are pyridazine, pyrimidine and pyrazine, where the position of the nitrogens is 1,2, 1,3 and 1,4. So the next thing is, if the benzene ring is fused with this pyridazine at either 3,4 position, the possibility for 3,4 position is along both sides. Here, if we start from here, 1, 2 and 3,4 position would be this one, and if we start from this nitrogen, the 1, then this nitrogen is 2, then 3,4 position would be this one. So because this compound is symmetrical, so in this way the if the benzene ring is fused along either side, this side or along this side at 3,4 position, the resultant compound would be the same, and that would look like this. Here these are the two nitrogens, this is the benzene ring. Now see, if we don't consider this benzene ring, then we start from here 1, 2, 3 and 4. Okay, so this benzene ring is fused at 3,4 position of this pyridazine and its name is cinnoline. So if we start the numbering system of the cinnoline, it would follow the numbering system of fused ring systems like naphthalene and anthracene. And according to the numbering system of the fused ring systems, we always start from this position at number 1, then number 2, 3, 4, 5, 6, 7 and 8. And these shared positions are named after this 4, it would be 4 prime, and after this 8, it would be 8 prime. And the other possibility for the benzene ring to fuse with this pyridazine is at 4 and 5 position. So at this 4-5 position, it would look like this. Here at first we draw pyridazine, that is like this, and then 1, 2, 3, 4 and 5. Then at this 4 and 5 position we draw a benzene ring, that is like this. So it also, we will start the number 1 system from this 1, then 2, 3, 4, 4 prime, 5, 6, 7, 8 and 8 prime, this carbon, this shared carbon, and its name would be thalazine. It is pronounced as thalazine. The pH is pronounced as a silent character. So this was the possibility for pyridazine to fuse with benzene ring, and the next possibility for benzene ring to fuse with pyrimidine. So for pyridazine, there lies 2 possibilities for the benzene ring, but in the case of pyrimidine and pyrazines, there is only 1 possibility for the benzene ring to get fused with this. So here this is the pyrimidine, and the benzene ring always gets attached with this position. So it's better to write it like this. The shared bond is doubly bonded carbons. It would look like this. So here it is 1, 2, 3, 4, 5, 6. Okay, and in the other way it is 1, 2, 3, 4 and 5. So in the case of pyrimidine, the benzene ring gets fused with it at 4 and 5 positions. At the 4-5 positions of the pyrimidine, the benzene ring gets fused to form the new product, that is quinazoline. That is quinazoline, and the numbering system for quinazoline is like this: 1, 2, 3, 4, 5, 6, 7 and 8. Here it is 4 prime and it is 8 prime. So benzene ring gets fused with this pyrimidine at only 4-5 position, not at any other position. And similarly for the pyrazine, for pyrazine is also, there is only 1 possibility for the benzene ring, that is here 1, 2, 3, 4, 5 and 6. Benzene gets fused with the pyrazine at only 5, 6 position, and the new numbering system is 1, 2, 3, 4, 4 prime, 5, 6, 7, 8 and 8 prime, and the name of this compound is quinoxaline. Quinoxaline. It is quinaxoline. So this was the general introduction of the diazenes. The next is, what is the pyridazine besides its structure formula? The pyridazine is actually a stable colorless compound that are soluble in water, and there are these three parent heterocycles, unlike pyridine, that are pyridazine, pyrimidine and pyrazine. Unlike pyridine, these are expensive and are not readily available. That means these are not commonly available to synthesize the other heterocycles. Rather, they are seldom used as starting materials for the synthesis of their derivatives. And there are only two ways in which a benzene ring gets fused with the pyridazine that we have studied, and only one way to get fused with the pyrimidine and pyrazine. And the striking aspect of the physical properties of diazenes trio is the high boiling point of pyridazine. The pyridazine shows high boiling point. The value for that is 207 degrees Celsius. So the boiling point is really high, up to 207 degrees Celsius for pyridazine. Now we see its synthesis. As there are so many ways to synthesize pyridazine, but for the sake of simplicity, we see its synthesis from only two ways. The first one is by cycloaddition of 1, 2, 4, 5 tetrazine with an alkyne. So the 1, 2, 4, 5 tetrazine reacts with an alkyne to form pyridazine. Let's see the general reaction for that. Here it is like this one. As the name indicates, 1, 2, 4, 5 tetrazine. 1, 2, 3, 4, 5. Here you see 1, 2, 4, 5 tetrazine. Tetrazine means as indicates Az. As indicates the nitrogen, and tetra, that means 4 nitrogens are present in this compound at the positions 1, 2, 4 and 5, as this 1, 2, 4 and 5. Here at these two carbons there are any substituent is present. Let's see. This is R1 and here it is R2. Now make it diaromatic in nature, and it reacts with alkyne. That means C, and here it is attached with R3 and R4. So now what does it do? It is shifted to this is shifted to this position, and this is at this. So at this carbon and this carbon, this arrow means this carbon would form the new bond between this double bond, this triple bond. 1 pi bond from this triple bond would form new bond between this carbon and this carbon. This double bond would be shifted between these two nitrogens, and this double bond would be shifted between this carbon and this carbon to form a new sigma bond. And the next step would be like this. as R3 and R4, and here this is the triple bond, one pi bond would be broken down and the other double bond would be like this, and here R3 is attached, here it is R4, then here it is R2, this R2 is here R2, here is R1. Then these two nitrogens with double bond, and these doubly bonded nitrogens would remain as it is like this. Now what would happen, this double bond would be shifted along this, it would be shifted to this, here this bond would be broken, this pi bond would be broken down, here when this bond would be shifted between these two nitrogens, it would also be broken, then this bond would be shifted along these carbons and it would also be broken down, and then our final product would look like this. Here it is R1, R2, here it is R3, R4, and here there is a double bond between two nitrogens, then this along these positions there would be one double bond, and this N2 would be eliminated in the form of N triple bond N, that is also may be written as N2, it would be eliminated. So for the sake of simplicity we just write it like this, minus N2, that means the N2 has been eliminated from the reaction medium, and as this is our final product, as these are at 1,2 position, so this compound is known as pyridazenes or pyridazine derivative. This is the first route of its synthesis. So second route of synthesis would be studied in the next lecture. Thank you very much for watching the video. Allah Hafiz.